Welcome to Passive House Canada and to our our final installment in our cold climate webinar series in partnership with Parks Canada. Thanks for joining us today. We're just waiting for a few more people to join and then we're going to get started. My name is Sarah Yadacito. Our session will be approximately 60 minutes in length today with a 40 to 45 minute panel discussion. And then we're going to leave time at the end for about 10 to 15 minutes for questions and answers. We encourage you to leave your questions in the chat throughout the session, and we will do our best to go through them at the very end. So without further delay, I'd like to pass things over to Chris Ballard, our CEO of Passive House Canada.
Great. Thank you, Sarah, and thank you to all the panelists who are joining us today, and to all the folks who've been our experts over the past 4 sessions. This has garnered, the cold weather, cold climate series has really garnered a lot of interest right across Canada. And I will say we even have a number of people signing in from other parts of the globe as well. So thank you everyone for lending your expertise to this and to sharing with us. Before I go too far, I just want to make a land acknowledgement. And I'd like to begin by acknowledging the Indigenous peoples of all the lands that we're on today. While we meet today on this virtual platform, I'd like us to take a moment to acknowledge the importance of the lands which we each call home. We do this, of course, to reaffirm our commitment and responsibility in improving relationships between nations and to improving our own understanding of local Indigenous peoples and their cultures. From coast to coast to coast, we acknowledge the ancestral and unceded territory of the Inuit, Métis, and First Nations people who call this land their home. So thank you, and thank you all again. So I want to first introduce Garth Grunerund, professional engineer who's the Asset Manager, Northern Ontario Field Unit for Parks Canada. And we've worked closely with Garth over the past number of months to put this series together. So thank you, Garth and Parks Canada for this. I'm going to turn the floor over to Garth for a second to give us an update on the Lake Superior National Marine Conservation Area project, the project that really sparked this series. Over to you, Garth.
Thank you very much, Chris. So yes, no slides today, but just an update on where we're at with our building. And it's slated to be constructed in Nipigon, Ontario. So about an hour and 15 minutes due east of Thunder Bay. And we're going into approximately 50% design right now is where our consultant's at. We've worked with the municipality to get land transferred over to Parks Canada, and that's almost done as well. So we're looking forward to having a net positive building that allows us to spend that extra energy on both cars, other electrical infrastructure that's required, charging batteries for boats and vehicles and other things that we can do, and then providing access to the grid. So we're still hoping for a Passive House certified building at the end of this. And our consultant and our internal parks team are working very well, and hopefully we'll have more information, more updates, and are expecting to be tender ready for the end of this calendar year, I believe. So that's the hope, and it's a large thank you to Chris, you and your team, as well as all the speakers that are here to get the word out about not only our project, but other Passive House projects that are going on throughout Canada and the world. And it's very interesting to make sure that cold climate is also being discussed. It's going to be a movement, and as we were discussing in our preliminary meeting on this, climate change is real, and we need to do our best to make sure that we're having as low impact as possible. So right. Thank you very much, Chris, to you and your team. Merci beaucoup et miigwech.
And thank you very much again, Garth, and thank you, everybody. And I will say that one of the key reasons we wanted to run the cold climate series was to make sure that we could educate as many people in Garth's area, so that as they move to tender, as they move to the construction phase, that there's lots of local organizations, local companies, local tradespeople who know something about Passive House and don't feel intimidated, feel that this is something that they could bid on, participate in, work on, because it is a big, prestigious project going on in this neck of the woods in Ontario. It's a great launching pad, a great discussion point to not only spread the word about Passive House, but to help educate folks so that they can take advantage of this opportunity. So I just want to introduce, today we have 4 panelists. They've been on our other series. And we brought everybody together today for sort of a general wrap-up conversation about Passive House. We've got a wide variety of experts here. We have certified tradespeople, tradesperson, we have architects, engineers, all with their own unique perspective on building to Passive House and their own experiences. We've explored those in past shows, so you can go on our YouTube channel and see some of the presentations that we've done already if you want to learn more. But I have the biographies of these people, of our panelists, are really quite impressive. I could probably spend the next 45 minutes reading everyone's biography, but what I thought I'd do today is just simply introduce them by name and the company they're working with. And then as they talk, as they make their points, if they want to work in a little bit more about who they are, or some of the projects they've worked on, we can invite them to do that. So let me go through our 4 panelists today. We have Marcel Studer, who is the principal of the Econ Group. Welcome, Marcel. Paul Hammond, our architect with Lowe, Hammond, Rowe Architects, Inc. Stuart Fix, principal of ReNü Engineering, and Doug Mackie, senior project manager, Western Canadian Properties Group. So welcome all 4, and thank you for being here. Thank you for being on our past shows. Like I said, these are well-attended events, and glad to have you here again. So we wanted just to have a panel discussion, and I'm hoping that each of you will build on the comments of one another. I'm going to start off with a lob ball question to whoever wants to join in. Maybe I'll throw it to Marcel's way to begin with. But Marcel and others, why Passive House? Can you talk a minute about the health and comfort aspects of building to the Passive House standard?
Great question, Chris. Yeah, and before, I was involved with the standard, or started to get involved with Passive House. I didn't necessarily tell them this is Passive House, because people would just get, oh, what's this German standard that we're trying to introduce here? So I just told them we're building a healthy and a comfortable building. And really, that's a lot of people oversee that aspect of the standard. They think, oh, it's very good at saving energy, which it obviously is, but all the criteria are based around thermal comfort. So that means that we don't have any cold surfaces inside our building. No cold surfaces means no chance of condensation happening. And no condensation means low risk of mold growth. And obviously combined with a HVAC ventilation system, that guarantees that we have a very comfortable building and also a very good air quality in our Passive House buildings throughout the season.
Good, good. And before we go any further, I will say, you mentioned German standard, but behind you, your backdrop is a very interesting and perhaps even odd looking building. Can you tell us a little bit about that?
Yes, I obviously put that on for a reason. So this is the original high performance Canadian home, and it stands still in Regina in Saskatchewan in a cold climate. And it was built and designed by a team around Harold Orr, who you probably know already. He's been quite involved in some of the latest webinars. I think there's a webinar coming up tomorrow with him again, a discussion. He is in his 90s, so he's experienced a lot in his lifespan. But this building has super insulated walls. It has triple glazed windows that they made themselves. It has an HVAC that they built themselves. It's really a pioneer building, and it was built in the late 70s. So kind of during the oil crisis, the first time we started thinking about resources and that they're not just going to be endless and that we have to do something to conserve energy. hence it's called the Saskatchewan Conservation House.
Very good. And it's a house I like to point to because the Passive House folks have clearly indicated that the DNA of this house is incorporated into modern Passive House standards today. So when people say that Passive House is the foreign concept, I like to point at this house and say, no, it's not really. There's a lot that was going on around the world. And some of it right here in Canada with some very innovative thinking. And you're right, tomorrow on our webinar, to put a plug in, Harold Orr will be coming back to talk to us a little bit about the things that he's involved with today, super insulation, new types of triple pane windows. The guy just won't slow down, which is great. And it's always a good conversation. So that's tomorrow. So thank you. We talk about the health and comfort benefits of Passive House in general, but maybe Paul, Doug, Stu, if you can just chime in and talk to us a little bit about, what are the long-term benefits of the buildings? What have you experienced? And why do you get behind a Passive House whenever you can?
Well, I think fundamentally the enhanced ventilation that comes from the HRV or an ERV system that can retain some of the energy that could be lost through exhaust. The system is going to give you that fresh air throughout, but it also enables one to temper that air and deal with potential cooling issues, which I think we're seeing more and more frequently because of the the heavily insulated Passive House systems, that heating becomes a problem inside, and so being able to tap into that mechanical system to provide tempered air can help mitigate long-term effects of rising temperatures.
Mm-hmm. Good.
I think that the points that Marcel made were very accurate. The healthy and comfortable aspects of Passive House buildings. I think from a cold climate perspective, one of the real benefits of that envelope and the inherent condensation resistance that it has is that you're able to have a higher humidity level inside. I mean, in these typical climates in the middle of January or December, it's common to have a 12% RH as your inside humidity level, which everyone has cracked hands and nosebleeds and all these. That's just part of life in the prairies, right? But when we get the air tightness level, the controlled ventilation, commonly with an ERV that allows transfer of moisture, and then the condensation resistance of the glazing, especially the frames and everything else, it's common to see 35-40% RH in these buildings, which is wonderful, right? That's very healthy for the occupants. And from a resiliency perspective, all of these things, also should create a building that lasts forever. If the the air tightness level and the detailing and the membranes are done correctly, which pursuing the ensures that there's no condensation or very, very little condensation being developed within the walls and the envelope, which is the primary mechanism that degrades an envelope over time, right? And same thing from moisture ingress from the outside. Again, if the cladding and all these membrane details are done correctly, you should have everything very well controlled. And at the end of the day, why can't a Passive House last for 100, 200 years? Sure, you can change the cladding here and there, but the bones of it are very resilient for the future, and with the energy efficiency that it provides, you're set for life. So I love that about the standard.
Yeah, that durability standard. And Doug, this is what I've heard about building to a Passive House standard is the quality of work that's required to get you there.
Yeah, we wrung our hands a lot on the project we did in Fort St. John about whether to build a double wall or a single wall with much insulation on the outside. And we chose to go to the single wall with much insulation on the outside. And BC Housing installed sensors for temperature and humidity to monitor how that wall was performing over the last couple of years. And indeed, it's performing very well. The wall cavity stays warm enough so you don't get any condensation inside. And that has got, like Stuart is saying, that's got massive benefits for long-term durability, because now the wall becomes self-healing. If there is a leak, or if there does happen to be a bit of condensation in there, it can dry. It can dry to the inside, it can dry to the outside. And that's massive.
Yeah. And maybe you can comment too, because some of the folks who are joining us today are in the trades or general contractors, and they hear passive house or they hear high performance, net zero, and it can sound a bit intimidating if you've not done it before. But what's the experience of the group in terms of building your first project or your second project? How intimidating, how difficult was it?
Yeah, well, maybe I'll speak to that first. And because there was, again, much hand-wringing when we were starting this project. None of us had ever built one before. The thing that we were most concerned about was the air tightness standard, especially on such a big building. And having 8 inches of insulation on the outside of the wall. Well, how do we keep the siding straight and things like that? In the end of the day, we achieved 0.18 air changes per hour, which is ridiculously low. And it was quite simple. It was taping the joints in the sheathing. So and deciding, in the end, the way we chose to do it with the high density mineral wool insulation, with the strapping over top of it, it looks beautiful. I don't know if you've seen the pictures of the project, but that siding is dead straight. So in the end, it was much less problematic than we had thought it was going to be.
I think that's the power of great detailing by Paul's group. You keep it simple, straightforward, rely on good materials in the right places doing their job, avoid a multitude of odd joints and undulations, and that makes the trade's job way easier. Put this membrane here, connect that corner, done.
Yeah,
and you can see that in the outcome, like Doug said.
Right. So jump in and get it done. I like to say, Passive House Canada, we do a lot of training. We have a trades training program, and I don't want to say it's just 3 days of training, but it really is just 3 days of training. And you're off to write your exam. If you want to write an exam, you don't have to. So it's not that difficult. It's not weeks or months of training in order to go work on a building or be a general contractor and work on a building. If you want trades training, it's 3 days long. If you're an architect, engineer, GC, it's a little more intensive, but I'm impressed by how easy it is and how quickly we can bring tradespeople up to speed. Many times we find on projects, the contractor will put a mock-up on site and just walk all the trades through what the mock-up of the wall is and how it all fits together. And literally within 30 minutes, 90 minutes, trades understand what they're going to be doing, and then off they go to do it. So again, we like to say it's not rocket science, maybe building science, but it's not rocket science. So it's easy to do. I'm interested in any thoughts anybody might have about sort of the overarching life cycle cost of the passive house. Any thoughts, any comments on that?
That's what we like to use as a basis for design decisions. And the passive house methodology, the focus on energy conservation first through envelope performance, air tightness, insulation, simple detailing, good glazing, etc. Those are the most cost-effective first steps to take in in life cycle cost reduction. and
Right.
you can put the numbers to it and see. And, you know, beyond that, you start to see, okay, now let's invest in renewable energy in PV on site or carbon offsets or, you know, other things. So there's no question that this method is the starting point for cost effective energy conservation and also climate change mitigation, right?
Right, right. So, and Stuart, I mean, this is your area of expertise too, but I've heard that in a lot of these passive house type buildings that because you can use simpler mechanical components, does that drive down the life cycle costs?
Yeah, it helps. And, you know, we find that one of the benefits of an excellent building envelope is that it drives the peak capacity of your heating and cooling system down to such a degree that electric systems are viable. If you look at, you know, heat pump, air source, ground source, and try to apply it to a code built building, especially in a cold climate, it's impossible. The tonnage that you need is insane. The costs are astronomical, and it's a non-starter. But when we follow this type of methodology, you know, you can get that system size down by 50% or more, and then suddenly that's, you know, a much more digestible endeavor. And then it also, because you're consuming far less energy in heating and cooling, it brings the operational costs back into line with electric systems. And so that's our home run goal, is to put a design on the table that is an electrified building, and it has a life cycle cost that's lower than a standard code built building with gas-based heating. And
Right.
again, that's a pretty monumental thing to achieve in a cold climate where the heating consumption is typically quite high, right? And we can do it. And that these buildings show that. Passive house methodologies and electrified heat pump systems, it gets the job done.
Good. Anyone else have any comments?
Yeah, I was just going to add, Stuart. I think it's also important if you've got a client who's, you know, debating whether to go to a passive house or not. You know, certainly life cycle costing is the factor, but also understanding the future costs of energy. And so they're on you know, especially with carbon taxes increasing over time and electricity costs increasing, you know, it has a larger impact if you go out, you know, 10, 20, 30 years from now. And your buildings are going to last 70 or more. You know, comparing what your future costs are is certainly essential, I think, in making the decision.
I think that honestly, that is the most compelling argument for building a passive house / net zero energy building, is that you are securing your future cost of energy. You've conserved enough on site that, you know, on-site solar generation can produce most or all of the energy you need, and therefore the cost required to invest in solar is the most you'll ever have to pay for energy, right? If you're worried about escalations in hydro or gas or coal or whatever it is in your area, you're capped by the price of solar. And even if you don't put the solar on at day one, you've always got it there in your back pocket if you've planned for it, you know, to invest in that when the price is right, the timing's right, and you're set for the future.
Right. And as Marcel started off, you know, it's all about, it's also all about that health and that comfort that comes with living and working in a passive house. So all of those are really important. So counterintuitive, because I know this comes up a lot, but counterintuitive to the cold climate series is, you know, the consensus here is that we can keep people warm in northern climates through the use of passive house methodologies. Can we keep them cool in summer times? How do we do that? Is that an issue in northern climates, keeping interiors cool?
Definitely, and not just in the northern part of Canada. I mean, we have examples here in southern BC, I'm sure definitely in southern Ontario, Quebec, etc., and in other places of the world. because we're building this super insulated thermos of a building, right? Any additional heat that's above what we want inside can lead to overheating. And obviously this, not necessarily just in the summer, it could be also in the spring or in the fall. And the first step to avoid that is really tackling the sun energy, controlling it on the exterior of our envelope. So that could be in terms of having fixed shading mechanism, movable shading louvers, etc., especially on the dominant sides where we have lower sun angles like the east and the west throughout the year. On the south, we can do a lot just with overhangs, because in the summertime, the sun is much steeper in the sky, and we can assure that there's no direct sun or a glazing and then leading to overheating. So that's the first step that has to be considered in any passive house. And I'll let maybe Stuart or some of the others talk about more the mechanical aspects that we can also incorporate in a passive house.
Sure. Any comments, folks?
Yeah, I certainly agree. I think it's been one of the biggest lessons that have been learned in the last 10 years, boots on the ground doing these projects, is that yes, passive house methodologies are extremely effective at reducing heating consumption, but the messaging that we're sometimes taught in the training about cooling also being a non-issue is not so accurate in many cases. And to be frank, I don't think we've done a project in the last 5 years that did not require active cooling to maintain comfort. And that's okay, is also the message. Most of the cold climate projects we do are actually cooling dominant. If you look at the annual demand profile for heating and cooling, there is a greater demand for cooling than for heating. But again, that's okay. And it goes part and parcel with this electrification strategy, heat pump based mechanical systems. Those systems are more efficient at cooling than at heating. So if you look at, again, the total energy consumed in a year, you can actually reduce the total consumption by pushing the envelope further into overheating or into a cooling dominant territory, but relying on your improved COPs, or coefficients of performance for the heat pumps to net out the difference. And we see that play out. And so again, this approach is also future thinking. If the climate warms or the climate changes, we're covered in heating, we're covered in cooling. We also, of course, like Marcel said, do our job first with the orientation, massing, shading, glazing design. We like to have operable windows to leverage natural ventilation and natural cooling when possible. So we do all those things. But at the end of the day, that heat pump system covers us off.
Covers us off. Very good. Any thoughts around this? The one thing, and it goes back to comments that Paul and Stuart were making early on about energy usage, and we're hearing now as we're out talking to hydro companies, electrical production companies, and even more importantly, distribution organizations, electrical distribution companies. They're very concerned. They're all for electrification. They really want to get us off of carbon-based fuels and over to cleaner electrical energy. But at the same time, I think there's in some areas of Canada anyway, there's a bit of a hesitancy because of the lack of capacity with local distribution. So they're very worried that the push to electrification may mean people, everything that's being, the homes that are being built, all requiring 400 amp service, and therefore local distribution having to really ramp up. So do you feel comfortable talking about electrification, but the amp diet or the watt diet that we can impose on that the passive house can bring to new buildings? So we talk about electrification, but it's not the same amount of electricity required if you're building to code. Have I got that straight? Being the non-technical guy in the room here, have I got that straight? Can anyone explain that a little bit more for us?
I'd be happy to. That's been one of our hills to climb on our larger projects in the last 5 years. As you said, as you electrify, your required service to the site goes up significantly. And what we find is that you can very quickly end up in rate tariff
Yep.
levels that are not previously, aligned with buildings, and we get demand charges. And these rate tariffs are typically developed to serve industrial or large commercial clients who have large machinery, they have a very high amperage, and presumably are most economical if they run all the time. And so, the economics of those rate tariffs are good for big draw that's consistent. But then when we turn around and on an electrified building land in that rate tariff, well, that's not our demand profile, right? We have very minimal energy consumption through much of the year. And then we have these spikes in the peak of winter, and we have a spike in the peak of summer. And unfortunately, the way those rate tariffs are written, that can, those two peaks in the year can actually set your escalated energy price for the entire year. And so when we do life cycle cost analysis, we've shown that just tipping into one of those demand charge rate tariffs can turn your op costs on their head. They can go up by an order of magnitude, which kills a project financially, right? So it's actually a major red flag for any larger scale project looking to electrify. Make sure you know what rate tariff you will end up on, and if it's higher than expected, then you need to look at peak shaving. And that's changed our mindset. We used to say air source heat pump. That's the way to go. It's the lowest life cycle cost. But in a lot of cold climates, it requires some supplemental, peak electric capacity in the winter, which in these rate tariffs with demand charges is a killer. And so suddenly the economics of geothermal ground exchange heat pumps are way better because of their peak shaving ability. And we're also looking at battery systems and other elements to peak shave and manage our demand on site. It's a big part of this.
Yeah, I personally think the battery technology will go a long way to help those peaks and valleys of electrical usage, because that's a problem when you're designing the entire electrical system, like Chris was saying, at the project, because you have to design for the peak loads, right? So all of a sudden, everyone's going from 100 amp panels in their condos to 200 amp panels, and you're using way more transformers, and it's just adding more costs. But the battery backup system will go, I believe, will go a long way to smooth out those peaks and valleys of the consumption demand.
And where we have the sunshine, of course, it allows for those for PV to play a bigger role. PV plus battery backup, all sorts of exciting things happening, exciting technologies happening. But it sounds to me like we've got a handle on a lot of it right now. This isn't something to be worried about or to be developed in future. We're dealing with it right now. So unless anyone wants to make any more comments around this, I wanted to take a second and talk about the impact of the Passive House standard on your areas of expertise, on your professional expertise, your trades expertise, and how you get buy-in from the folks you're working with.
Oh, okay. I guess I had a good friend of mine that it was investing in a new building supply company, and he asked me, what will be the latest, greatest things to come down the pipe in building supplies? Because they wanted to get into whatever that was going to be. And I said, well, I think the writing's on the wall that you really, especially we've seen it this summer, fire resistance in building materials is going to be a huge thing in the future. And the way we're building a lot of things now, they're not very fire resistant. However, the way that Passive House is, and I'm thinking in particular about buildings that have, let's say, a lot of mineral insulation on the outside of the building. And the other thing about Passive House is it sort of requires the use of durable long-term materials, right? one of those could also be metal roofs, and the simple form factor of passive house building really aligns himself well to the use of metal roofs. And both those things go a long way in fire resistance of structures in the western part of North America in particular. So when you start talking about things like that, that really opens people's eyes up, because I think there's, to some degree, there's some misinformation out there about climate change as a big argument, if it's even happening or not. But the fire resistance thing is, everyone's on board with that. So that's one of the things that we've got really good buy-in now. And the project, I'm starting up a project. Actually, we have a sod turning this afternoon for a native group in Coquitlam here, and they have both of those features. They have PV panels on the roof, it's metal roofs, and they have mineral wool insulation on the outside of the building.
So that's the buy-in that was required when you talk about fire resistance. It reduces resistance to the passive house way of building.
Exactly. Yeah.
Paul, do you run into anything, resistance, or how you've overcome resistance in your field to passive house?
Yeah, I think 10 years ago, yes, you would see real resistance. We were talking with various developers doing condominiums projects, and there's talk of doing high performance buildings, and they've crunched the numbers, and people at the time, people were not willing to pay an extra $2,000 to be in a high performance building. They would go next door in a building where they didn't have all the systems to reduce energy consumption. And in particular, condos, so developers that are selling buildings, they weren't interested in it either. And so I think the primary change now is with the building codes. And I really believe that systems like Passive House and LEED are really what the end game is, to change how we build. And I think it's really starting to happen with the latest BC Energy step code that's in place. We're now seeing most of our buildings minimum step 3, and a lot of them, especially for BC housing, affordable housing projects, they're required to hit step code 4, which is very close to passive house energy performance. So I think that argument is it's not as strenuous these days, and especially with these reports that came out again on Monday, as you mentioned, really citing the climate emergency that we're facing. I think the struggle will be a lot less going forward.
Right. And as Marcel said earlier on, and I've heard this from people who've been building residential MERBs, they sell their units not necessarily based on energy savings, because right now energy is relatively inexpensive for a single family residential or a MERB. But what they really sell it on and how they overcome any additional costs, although those are decreasing, is talking about health and comfort. You walk into a passive house building of any type, any form, shut the door, and people are immediately impressed by how quiet the environment is. Spend any time there, and Stuart will tell you, your skin does better. You don't get the nosebleeds because of good humidity, and it's especially in an urban setting, unbelievably quiet, and that's so positive for our mental health. But I'm not sure, Stuart or Marcel, if you've got any tips or tricks, anything you've come across in terms of overcoming. Stuart, you talked about that whole life cycle cost as you can now crunch the numbers.
Yeah, that's always been our pitch. I mean, we're operating in Edmonton here, which is the most progressive city in Alberta, but that's not necessarily saying much, right? So we've been here for 10 years and used to dealing with the locals, as it were, and having to convince them that investing in energy conservation is a good idea. And that's always been our pitch, is the life cycle cost is the lowest, and you get all these benefits. It's healthy, it's comfortable, it's quiet, and it's, you know, resilient. So and that to owner operators, whether they be a single family home owners, builders, or affordable housing outfits, or you know, municipalities, administration buildings, that type of thing. That argument, that, you know, bundle of arguments really resonates, we find, and they, when they see the numbers, they say, oh yeah, I like that.
So
You know?
that offsets the maybe 10 years ago, the passive house was a lot more expensive, but it's not that way anymore.
Yeah.
With all the expertise we've got around the table here, we can demonstrate that it's pretty much similar to building at code. So I get the last word to Marcel on this. Now, Marcel, you're both a passive house certified trainer and architect. Talk to us about trades for a second, and any issues you've had and how you've overcome those.
So first, maybe just one last thing. I agree with everything you said. What I tell my clients sometimes, especially since step code has come into effect now, when you really want to build a building now that's going to be obsolete in 10 years, you want to protect your investment on your property and build to the highest level of step code. But talking about trades, obviously that's very important. And I think a lot of it has to do with them being educated and understanding what's going on. If you have a plumbing contractor or electrical contractor coming on board, and for them, you know, they see their part of the work, the wiring or the plumbing they have to do. And if they don't know anything about air tightness and why it's important, they don't really care about the airtight layer, and, you know, they don't pay that much attention. So it's as simple as, you know, having a toolbox meeting at the beginning of the job, maybe having a mock-up explaining the layers, and really it's not that complicated, and just get the buy-in from the trades by them understanding what the bigger picture is. And then, you know, telling them the benefits and all of that, and that's really that's a holistic system, and everything plays together, and you're part of this team that creates this amazing high-performance building. And, you know, and we use a lot the same traits again. Obviously, there are some that, you know, maybe don't want to get it, and others that most of them understand it right away. But, you know, we're in a single family home business. So it's a little bit different than from the larger scale.
Mm-hmm.
Yeah, there's been one more kind of major change that's happened recently in the marketplace. I mean, the company I work for, we are developers. You know, we build our own projects, and we build projects for government organizations as well. But in years past, you know, most of the multifamily places that were built were strata units, you know, to sell individual units. And now there's been a big change where a lot of the buildings that are being built are purpose-built rental buildings, you know, build and hold for the developer. And I don't know if you're aware of this, but, you know, in the marketplace, there's a concept called a cap rate, where the value of the building is related to the net operating income of the building. So that you can increase the net operating income of the building either by increasing your rents or by reducing your operating costs. So when you build buildings that are durable, you know, long-term durable and energy efficient, you really reduce your net operating income, and thus you increase the value of the building. So.
Yeah, that's a really good point. As purpose-built rental grows all across the country, and government is investing in that area. So, yeah, very good point. So, yeah, listen, before I get on to the next question area, next topic, I just want to say there's some really good comments and questions being posted to our chat section. We may not be able to get to them all, but if you have a comment, a question, feel free to plug it in there. I don't want to detract from the great conversation we're having. So, but feel free if you've got thoughts, things you think Passive House Canada should be focusing on. We know that Stuart's comments earlier on remind me, as we talk to government regulators and the electrical industry about those rates on passive house buildings. We know about the importance of the building code, and that's an area that Passive House Canada has been very involved with, the national code, the provincial codes. So, and we'll continue to be involved there. So if folks have some ideas about how to influence that, we're all ears. But speaking of the code, government policies at all level are moving that needle on building to net zero buildings. By way of prefacing the question, there are 501 municipalities across Canada that have declared climate emergencies, and many of them now are calling Passive House Canada and saying, we've got to actually now put those words into action. And everyone knows the impact buildings have on GHG emissions at the municipal level. And they're looking for solutions. They're looking for a building standard that will help them drive down GHG emissions and meet the provincial and federal targets. So that's good news for those of us involved in the Passive House, the net zero type building. But the question remains, and this is one of the questions I get all the time, is there capacity within the building industry to address this growing demand? How do we, as members of this building industry, build this capacity? So what are our thoughts on this? What are your thoughts on this, building capacity?
I think, like you mentioned, a lot is driven by the codes, obviously. Unless we have to do it, the majority of the buildings won't change. I mean, there's always the early adopters and the pioneers. So that's definitely driving it. But then it's also the industry capacity of producing those materials. And for some of you who have to try to order mineral wool in the last few months, probably experienced that one-on-one. Like there's a 6 months wait time now to get mineral wool, because when we should have seen that coming, everyone wants more insulation and the plants are running 24/7 and they can't keep up with the demand. So hopefully that will be a lesson and a trigger for other companies to set foot in North America and start producing, European companies start producing insulation materials. And it's always that chicken or egg thing, what comes first? Is the demand, or you can't just build a multi-million-dollar factory and then hope you're going to sell the product. So it needs that build of the demand that we're really just experiencing now. And then it makes it attractive for businesses like, wood fiber insulation manufacturers to actually set up plants in Canada.
Yeah.
Material supply is certainly a challenge, Marcel. I'm also thinking about advocating high performance, low energy use design directly through industry associations and educational institutions. Much like what Passive House Canada is doing right now, and reaching a broader audience to really, explain the necessity. And I think the 2030 challenge, that's not far away. It's 10 years. And so, I think it's a absolute essential of all of us to pursue this path.
And it has happened already to a certain extent. I mean, I don't want to be pessimistic, but just look at the windows that we have available now, just locally in BC, and compared to 5 years ago. So if that's any indication, and those are high, technical components of our, high performance buildings, and that's something someone can do in a little wood workshop, right? So we went from having one that was imported to like having 6 or 7 now just in BC, and there's more across Canada as well. So if that's any indication, I think Canada is quite good at adopting these things and seeing opportunities, especially because the kind of culture around smaller businesses as well, and some of them can be produced like that. I would say it would take much longer in Europe, where I'm originally from, to adapt something like that. So I'm actually really impressed how quickly the industry is changing here and how quickly people are getting on board, and the manufacturers as well.
Yeah, and go ahead.
I just think we have to keep doing what we're doing. I think there's a real swell in momentum growing here in the last 5 years, and I think it's going to keep growing. And like others have said, it's the codes that will backstop the low performing side of industry, but at the end of the day, we try to pioneering these new projects, pushing into larger scale, different building types, figuring out the quirks of each, and then it's always easier to disseminate information after you've learned the lessons. You can share in 5 minutes what took you 2 years to learn. So I think we just keep doing what we're doing, and we have excellent leadership with organizations like Passive House Canada, liaising with governments and other bodies, and we just keep at it, and it's gonna get there.
Well, and that's wonderful to hear. And I know at Passive House Canada, a few points. We talk about marketplace transformation an awful lot, and my fear is that Canada will miss out on job creation as the marketplace transforms, and we are buying more and more high performance building materials and components. What terrifies me is to see us importing a lot of materials when we could be creating jobs here in Ontario and Quebec, all across the country, really, when it comes to manufacturing. So, we've worked closely with Fenestration Canada to bring their members up to speed with the pending opportunities. I'll give you a short little example. The Toronto Community Housing Organization, which is the second largest social housing organization group in North America, second only to New York. They are retrofitting, they have plans to retrofit some 200 towers, medium and tall towers over the next few years. And they estimate that they will need a minimum 200,000 passive house quality windows for their buildings. They're going for an interfit type standard to reduce their operating costs and provide healthier living space for their clients. 200,000 windows, minimum 200,000 windows, it really changes the world, the manufacturing world here in Canada. We have to make sure that those windows are made here in Canada, that we're not importing them, that we're creating jobs here. So that's always my pitch to the regulators, to our civil servants, to our politicians, that this really presents a wonderful opportunity to create jobs right here in Canada. And I'll get off the boat. I'll get off that stump. That's a lot of the advocacy work we do is talking about the opportunities that this move to net zero, this move to passive house will bring our country. So that's great. The other thing, sorry, and I'm sorry to steal the spotlight for one more point, is Passive House Canada's, I think we're the largest trainer of passive house folks in the world. According to the Passive House Institute, we have more people taking the global exams than any other group. But what we want to do is we want to share the wealth. We want to train the trainers. We've got the courses. We've got the experts. We need, we're doing the outreach to colleges, to trade schools, to unions, to universities, to take the passive house information and teach their people. I mean, quite frankly, someone who spent all those years becoming an engineer, becoming an architect, to have to take passive house training and be certified doesn't make sense. It should be incorporated into what they're doing already, what they're learning already. So we are advocating with educational institutions to include fundamental passive house training within their course curriculum. But of course, any organization, any professional organization that wants to work with us, we're quite happy to train the trainers and get them on their way. So enough of that. Let me move on to the next thing. It's always great. And one thing I find about the passive house world is that people share. They share what worked. More importantly, they share what didn't work with some of their projects, so that the rest of us can learn. I think it was Stuart who was saying, what took 2 years to learn, we can teach in 5 minutes. So can each of you talk about one of the most important lessons learned for you and why you would never do that again. But what's an important lesson learned for you?
Maybe I can start. I've probably been the longest at it. So something that Doug mentioned earlier on today is like, it's really not that hard to do good air tightness. A lot of contractors, carpenters are afraid of it. But it doesn't just start or finish with us. It starts in the planning of the building too. And one of the biggest things I learned is to keep things simple. Line things up, keep them simple. Don't overcomplicate the building envelope, because you're opening yourself up for more trouble and more potential of mistakes.
Mm-hmm.
I know that people try. I don't want to say everything.
Yeah, I think that's some great lessons. Same, our approach to the Fort St. John project was start with a simple form, and you add complexity if required as you develop the design. And I think the main difference is having the hands-on energy modeling, so you can actually understand the impacts of your design decisions very quickly and decide what's working, what's not, and you move the project forward, always checking. You discover new thermal bridge issues that have to be dealt with, and you devise a detail with informed consultant team, and you work your way through it. So in the end, we found the process for Fort St. John very informative, exciting, and not that difficult. And then of course, it's relying on the execution in the field that's going to give you the results that you need. So congratulations to WCPG on that effort.
Doug, Stuart?
For me, I'm probably going to echo a lot of what Stuart will say, but we had sort of fear of a very complicated mechanical system, and to some degree that proved out correct. I think I don't want to get into the weeds on it, but we used a centralized HRV system, and it's a lot of piping, a lot of corners, and to do it again, I would have kept it a little simpler and went with individual HRVs in each unit. And I realized that can complicate other things down the road, but so that would be one of the things I learned. But for sure, the biggest thing was just not to be afraid. Like just the air sealing turned out to be much easier than we thought it was going to be. Getting the trades to buy in to do what they needed to do was really easy. I think Canadians, for the most part, are right into this, and like the trades were absolutely not a problem to deal with. My general concern is one with all of construction, being a developer and being a boots on the ground kind of guy, is we just have a problem in Canada with the number of tradespeople and qualified tradespeople available. So I think we need to do a better job at promoting the trades as a legitimate career choice. So
fine. Stuart, final words?
Yeah, I'll be quick. I have three major lessons learned over the past decade. The first is don't trust the PHVP when it comes to predicting overheating. It's not that the PHVP is flawed, it's just the way it's set up. It's very easy to trick yourself into thinking you do not have an overheating problem. On a larger project, I would always check your math with a higher end energy modeling software like IES or something. It will more accurately represent the overheating that's present. The second one, echoing what Doug said, I would not ever do a central ERV in a large apartment building ever again. ever again. The common knowledge that we had going into it was that approach would be most cost effective, and I think by the end of it we had a hell of a time balancing it. You can envision an air system with some 250 diffusers, and you're trying to get 20 CFM, let's say, at each diffuser. It's quite insane, honestly. And unless you have very, very highly experienced tradespeople at doing that, and that's not a knock on the folks that we worked with there, that's very you unique skill set to have in Canada right now. Unless you have those people, you're going to have a real hard time balancing that. And then, so the third one is this electrical utility rate tariff. Make sure on a larger project, make sure you know what you're getting into if you plan to electrify the building from day one. You know, as you do life cycle cost analysis, the cost of energy on the expected rate tariff should be what you build into the analysis. Otherwise, you'll be up for a very large scare when you first talk to the utility.
Good, thank you very much. And you know, when we kicked this this seminar off, I looked at my time and we were 13 minutes into it, and I thought, oh great, we've got all kinds of time. And now it's 1 minute past the hour, and we're 1 minute past 2. But there's so many great questions. I hope the panelists can stay on for a bit, and our audience can stay on for a bit, because I want to turn the floor over to Sarah from Passive House Canada. She's been winnowing through some of those questions and can present them to you. So if you can stand by, we'll do that. I haven't even got to all my questions that I wanted to talk about, but I think we got some good things discussed. So Sarah, throw a question to the panel if you would.
Sure. Thanks, Chris. One of the earlier questions that came through at the beginning was, please comment on the importance of shading, the first passive house line of defense.
Yeah, I think that's absolutely essential. You know, just reflecting on the project that we did in Fort St. John, you know, obtaining enough, a substantial amount of winter solar gain to reduce the energy costs to deal with -40 temperatures, you know, that it became a priority. And so putting solar shades that would block that sun in the winter, well, primarily for the purpose of the summer, trying to block out the heat gain, you lose the gain in the winter. So, you know, it seems, and we're seeing this more and more now, the more like European buildings where you have external shades that are motorized. And that gives you, I think, the ultimate flexibility to use a solar gain when you need it and take it away. When you stick with a fixed, you know, solar shade, you've got, you know, many other things to consider.
Okay, thanks, Paul. Does anyone else have anything to add on that one?
I think it's a balance. Shading is a very key tool in the tool set. However, each project will be unique. You know, if you set out on a clear plot of land to design the most optimized, cost-effective passive house possible, for sure, shading is a very powerful tool. You'll end up with a you know, east-west elongated box, loss of south glazing, and really no other glazing. And then shading in that context is incredibly powerful. But, you know, jump to the real world where you're commonly building on infill lots of a certain shape and geometry with other elements around them. Perhaps the building is constrained to a different footprint than might be ideal, and you end up having to work with it. And so basically, and as kind of Paul alluded to, each project will be different, and you can look at shading and what you can get out of it, and you know, just make sure you don't try to leverage too much from shading when it's not the right tool at that point. Maybe it is mechanical cooling, or maybe it's a different tool. So just always keep your eyes up at the high level and make sure you're seeing the whole picture.
I just want to second what Stuart said, and I'm going to turn it around a little bit, because sometimes we forget about shading that's already there around us, because we're not just looking at the building. The projects in the Whistler, Pemberton area, where there's high mountain ranges around it, you got to factor that in. You might think you're on a big exposure lot, but then that sun disappears behind the mountains. There could be forests, there could be trees, neighboring buildings. We have to look at that, and it's very key that we precisely input that. And it's easy to do now with Design PH, which is a SketchUp plugin. So you just three-dimensionally draw up your surroundings, and you can model at any given time of the year how much sun you're going to have on your windows. So it's probably one of the most important things to be diligent at, because it plays back into a lot of things, into the heating demand, into the cooling, overheating scenarios. So it's not just, you know, thinking about it at a later stage. It's begins at the very beginning on the broad strokes of the design.
Okay, great. Thanks, Marcel. Another question that came in was, what comes first, windows, air barriers, or insulation?
That in terms of priority, if we had a retrofit and we have some things we can choose first that make the most impact, is that right?
This question came from Harvey. Is Harvey still here and can maybe elaborate on that?
Yeah. He says yes.
Okay. I mean, it really depends, right? I always say that. It depends on your retrofit. Can you externally add insulation? Do you have to do it on the inside? Is it a heritage building? In my opinion, when I talk to people, like changing your windows, if you have only one measure to do, that would be the first thing I do. I mean, you typically can't touch the air tightness that easily. You can always get to the windows. Updating them from a single glazed metal frame to a triple glazed high performance window will make a huge difference. So that's just my thought.
Air tightness gives you the best bang for buck in a new build. If you're looking at, let's say we can't do everything, but we have, you know, the goal of doing something, even if you built with, you know, low code level envelope, you know, if you look at doing that envelope with a passive host level air tightness, there's it's a huge benefit.
Right. And we did hear from Paul earlier on and Marcel that really it all starts with good design, right? It all starts with, if you're for a new build, all starts with good architecture.
Mm-hmm. Okay, I know we're 6 minutes past, so maybe we'll just do a few more quick questions. Scott from the audience said, please speak about passive house in conjunction with net zero carbon construction.
So
to me, they're the same thing.
Yeah.
It's not the same. Yeah, so we're going to separate them out. So let's talk about low carbon first, maybe. Or maybe net zero, that's kind of more obvious. So passive house doesn't demand net zero. We have different tiers. So we have a classic approach where we just really working on conserving, which is always the first step in any passive house design. But once you conserve the amount of energy that you're using, it's much easier to add on renewable energy like photovoltaic, wind, all of these nice things. For the carbon, embodied carbon, so it's really talking about the energy that's put into the building materials that we use in the building, right? And the energy in terms of how much CO2 got emitted as well into the manufacturing, into the transport, and then even into like the recycling of the material. So the obvious move there is, and this really works well with our building culture in Canada, is use more naturally grown materials, building materials, wood being the main one, right? We have lots of it, and we have lots of different variations of it. And the International Passive House Institute is just integrating a carbon calculator into the planning package for passive house. So this is coming very soon, I think within the next year. We will have an integrated calculation tool to look at embodied carbon for the entire building.
Okay, thanks, Marcel.
So I think it's key.
Oh,
there are different you know, levels down the rabbit hole that you can get with this conversation. And I agree with everything Marcel said. From a very high level perspective, to me, the goal with all of these approaches and standards and is climate change mitigation and improvement of the health for occupants in the buildings, right? So a net zero energy building can best be achieved by first following passive house methodologies. You may not actually stop at the passive house targets. You may, through life cycle cost analysis, decide that in this specific instance, maybe a little bit less insulation or maybe a little bit different, you know, target outcome is optimal. And that's okay from my professional experience. If we can deliver a carbon neutral, carbon positive building in a cost effective manner, that's a win. And there's no question that using the methodologies of air tightness, insulation, shading, massing, all this stuff that are embodied in passive house training, that will get you the most cost effective start in that path. And then where you stop, that's, you know, that should be a project specific decision in my opinion, based on life cycle cost and all sorts of other, you know, if you want to get into embodied carbon, you know, that's a parallel decision. And by all means, we should be doing that too, but that's not specific to either of those outcomes.
okay,
Sarah, if I can throw just a
Mhm.
very quick two cents worth in, you know, a lot of the focus that we face is about you know, net zero, efficiency first, those kinds of discussions we hear, but it's all for naught if we're not creating healthy, comfortable buildings. And that's one of the reasons that I think, you know, we started off talking about the principles of Passive House. We may not, you know, your project may not get to Passive House certification, but you know, it has to be healthy and it has to be comfortable, and not just low energy. So keep all of that in mind, and we find that, you know, my experience and that of others is the way to check all of those boxes is following the Passive House principles to the highest level that you can. But let's not just talk about energy efficiency. Let's also talk about healthy, comfortable buildings.
Mhm.
That's a great point. Chris, I think that I think maybe one more question that I have in the chat here, and then I'll pass it over to you. This one came in from Kevin. It says, please comment on Passive House for schools and why there is so little uptake for this no-brainer.
That's my opinion totally. Just do it. There's not enough there yet. There's enough schools that need retrofit, were built in the 70s with ugly chain link fences around it. Let's make them beautiful. It's the best. It's a learning environment for our kids, for adults. You need fresh air, comfort. It's a no-brainer totally to do that. I think it has to do with the structure, the way the school boards are set up and the financing of it. And it's a bit of a dinosaur here, and maybe it needs to be kind of, you know, that needs to be changed. So it's more, I think, an organizational problem than, you know, that's maybe why we don't see so many.
Yeah, the procurement method, I think, is outdated, like you're saying. There is another element here too, though, is the ventilation rates required by building code, dictated via ASHRAE, are commonly higher than what the Passive House PHVP would suggest, and that's in a school environment, for example, or a very dense occupancy, that comes more to light. And this is very important if you undertake a project shooting for Passive House with an occupancy like that, that from day one you have a strategy to deal with that ventilation rate.
Very good point, Stuart. And it's you know, it's one of those issues that, and this is why we're excited to work with Parks Canada, because through this whole process, Parks Canada has shown really enlightened leadership when it comes to design and wanting to shoot for Passive House. And giving us a platform to talk to more people, especially those interested in cold climate building, talking to more people about Passive House. So, Sarah, is that it for? I know we've got so many more questions, and there's a really great discussion happening on the sidebar chat room. So, yes. This webinar will be on our channel, as were all of the others for the Cold Climate series. I want to thank our panelists today. I've got so many more questions that we could just keep going, but we'll call it a day. So thank you to Doug and Paul and Stuart and Marcel and to Garth from Parks Canada. And thank you to everyone who joined us today. You know, I'll put a plug in if you're interested in one of the originals when it comes to the Passive House movement. Join me tomorrow at noon Eastern time, where I'll have Harold Orr back on talking about whatever Harold wants to talk about. We'll be all ears and let him drive the conversation. But it's really neat listening to one of the pioneers who still goes to work every day, working to build better buildings. We have that. Visit our website, passivehousecanada.com. There's all sorts of great training and information that you can find. If you have questions, you'll probably find the answer there somewhere. And check out our education page. There's all sorts of education going on. If you're someone interested, one issue or one symposium I will point out to you this September, we have the upcoming Tower Retrofit Symposium. We're doing that in collaboration with the Tower Renewal Project. So if there's any interest in your jurisdiction to, you know, how do you renew, how do you retrofit towers to high performance standards, come and join us in September for that. But for now, I will say thank you to everyone who joined us, and we look forward to seeing you in the next series. Take care, everyone.
Bye-bye.